this video, we're going to take a look at the topic of vectors. Now, you've probably already seen column vectors which look like this. A column vector describes a journey from a start point to an end point, and we can draw these onto a grid. So let's take a grid and draw this column vector. This vector tells us to go 6 to the right, and then 3 down. So a diagram of this column vector would look something like this. In this video though, we're not going to use column vectors at all, and we're certainly not going to count how many squares we go left, right, up or down. For this topic, all of the vectors are going to be renamed using algebra. For example, this vector here, to get from the start point to the end point, could simply be named with the letter A. Your exam paper will use bold letters to indicate that they're representing vectors. So if the letter is not in bold, it won't be a vector. When we handwrite maths though, it's very difficult to write in bold. So many people will underline the letters that represent vectors, like this. Now we're going to take a closer look at how we write down vectors. So imagine we had 3 points, point O, point X and point Y. We could describe the journey to get from O to X using a vector, and we're going to call this one A. To write this down using vector notation, we would say OX with an arrow above it, and we could read this as the vector from O to X, and we name that one A, so it's equal to A. Now let's add a second vector to this diagram, this time starting at O but going to Y, and we'll call this one vector B, since it's different to the vector A. This time we started at O and we went to Y, so this is the vector from O to Y, which is equal to B. If we decided to do these vectors but in the opposite direction, so starting at X then going to O, that would be the vector from X to O. If we were to do this though, we'd need to reverse the direction of this arrow. And if you reverse the direction of the arrow, you need to change the sign of all of the terms of the vector. So where this vector was actually positive A, it will now be negative A. So the vector from X to O would be negative A. In a really similar way, the vector going from Y to O goes in the opposite direction of that arrow, so instead of B, it will be negative B. Let's revert this diagram back to its original state, and we're going to now consider the vector from X to Y. The vector from X to Y would look like this. Now you might think we're just going to give this another letter, for example C, but it's actually possible to describe this vector using A's and B's. We need to consider a way of getting from X to Y. Now we're not going to go there direct along the arrow we just drew, but we could go there using the other vectors that we already have. So if we start at X with this green dot here, and go along to O, we've just gone along the vector from X to O, so that's XO. Then if we go from here down to the point Y, we've just done the vector from O to Y, so OY. We started at X and we've ended up at Y, so we have done the vector from X to Y, we just went an indirect route, from X to O and then O to Y. And it doesn't actually matter how you get from X to Y, as long as you go across vectors you already know. So we could say that the vector from X to Y is equal to the sum of the two vectors from X to O and O to Y. Now we know what those two vectors are. So to get from X to Y, we're going to go from X to O first, and X to O goes in the opposite direction of that vector A, so it's negative A, and then we go from O to Y, which was positive B, so we add B. So the vector from X to Y is negative A plus B. Now some people will write this the other way around, it's considered slightly neater to write b minus a rather than negative a plus b. Let's try and apply this to some slightly more complicated situations. So in an exam question, you could be given a diagram that looks like this, and then you'll be given all of the information that's represented on that diagram. For instance, OQ is 5a, and you can see that on the diagram. To get from O to Q is 5a. QR is 3b minus a, and once again that's on the diagram, and so is from O to P being equal to b. Then sometimes they give you extra information that you need to use. For example, the vector from O to Q is the same as the vector from S to R. We can see the vector from O to Q on the diagram, that's 5a. So the vector from S to R, which goes from S to R, must also be equal to 5a. Now let's use this diagram to answer some questions. So sometimes a question might say, work out the following in terms of a and b. And we're going to start with the vector from Q to P. So we need to start at Q, so I'm going to place this green dot on Q, and we need to go to P. But we want to travel along vectors that we already know. You can see we could go there direct, but we don't know that vector yet. So instead, we're going to go from Q all the way down to O, which is the vector QO, and then from O all the way across to P, which is the vector OP. So we could say that QP is equal to the vector from Q to O plus the vector from O to P. And we know both of those vectors. The vector from Q to O is the opposite direction of that 5a vector, so negative 5a. And the vector from O to P is just b, so it's plus b. So this is the vector from Q to P, negative 5a plus b, which if you wanted, you could rewrite as b minus 5a, but I've left it like this, which is also acceptable. Now since we found this one, I'm going to mark it onto the diagram as well. So to get from Q to P, I add an arrow going from Q to P, and I call it negative 5a plus b. Now let's try and do another one. This time the vector from P to R. So you can see that we can't get from P to R directly, but we could get there by going from P to Q first, so the vector PQ, and then from Q to R. So we add to this the vector QR. Now we do know both of those vectors. From P to Q is the opposite direction of that arrow, negative 5a plus b. So we need to do the opposite sign of those terms. So instead of negative 5a, it's positive 5a, and instead of positive b, it's negative b. Then we went along the correct direction for the arrow from Q to R, so that must just be 3b minus a. So we add to this 3b minus a. Now just like when we have algebra, we can simplify these vectors by collecting like terms. We have 5a minus 1a, which is 4a, and we have negative b plus 3b, which is positive 2b. So the vector from P to R is 4a plus 2b. Let's put this onto our diagram as well. Now we're going to do one more vector on this diagram. We're going to do the vector from P to S. So to get from P to S, we'll take that green dot and we'll go from P to R first. So that's the vector PR. And we're going to add to this the vector from R to S. So RS. We can see PR, we just found that one. It was 4a plus 2b. But going from R to S is in the opposite direction of that vector with 5a on it, so it must be negative 5a. Then we collect like terms again here. We've got 4a minus 5a, which is negative a, and then we just have plus 2b. So from P to S is negative a plus 2b. Now let's have a look at a second question. So in this one, we've got OABC, which is a parallelogram, and here it is. And we've been told some information about two of its vectors, OA is 2A and OB is 6B, and you can see both of those on this diagram. Then we're going to answer some questions. So this one says, work out the following in terms of A and B. And we're going to start with these two vectors, BC and AC. Now looking at the vector BC on the right hand side of this parallelogram, that will actually be the same as the vector from O to A. Since these two lines are parallel and the same length, the journey from O to A is exactly the same as the journey from B to C. So BC is also 2A. In a very similar way, the vector from O to B is the same as the vector from A to C. So AC is 6B. Next, we're going to add some more information to this question. M is the midpoint of AC. So halfway along the line AC, we're going to find the point M. And we need to work out the vector from A to M. So to get from A to C was 6B. So to get from A to M must be half of that vector. So we could write that AM is half of the vector from A to C. And the vector from A to C was 6B, so it's half of 6B, which is 3B. So the vector from A to M is 3B. Now what about if we ask for the vector from O to M? This time we're going to bring that green dot back, and we're going to consider a journey from O to M, trying to go along vectors we already know. So to get from O to M, we could go along the vector OA first, so we have the vector from O to A, and then we go along the vector from A to M, so we add to this the vector AM. Now O to A we can see on the diagram, that's 2A, and A to M we just found out, that was 3B, so we add to this 3B. So the vector OM is 2A plus 3B. Now let's add some more information to this question. The point N is the midpoint of OC. Now we don't actually have the line OC drawn on, so I'm going to add it to the diagram as well, and the point N must be halfway along this, so somewhere like here. Next we're going to try and work out a vector for ON. So since N is in the middle of the points O and C, the vector from O to N must be half of the vector from O to C. So we could write that ON is half of OC. The problem is we don't know the vector from O to C. We're going to need to work that out first. So we can write 1/2 and then put a bracket, and then inside this bracket we'll work out the vector OC. So let's bring the green dot back, and to get from O to C, we could go from O to B, which is 6B, and then from B to C, which earlier we knew was the same as OA, so 2A. So we've now got half of 6B plus 2A. And for this you can just expand the bracket just like you would with algebra. Half of 6B is 3B, and half of 2A is 1A. So ON is 3B plus A. Now let's have a look at another vector. This time we're going to look at the vector from N to B. So let's bring the green dot back. We'll start at N and we'll need to find a journey to get to B. So I'm going to say we go from N to O first. So that's the vector from N to O, and then we go along O to B, so we'll add to this the vector from O to B. Now the vector from N to O we don't know, but we do know the vector from O to N, we worked it out in the previous part. So the vector from N to O must be the same as this one, just with opposite signs. So instead of 3B plus A, it's minus 3B minus a. Then we need to add to this the vector from O to B, and you can see that's on the diagram, that's 6b. Then we just collect these like terms. We've got negative 3b plus 6b, which is 3b, and then minus a. So from n to b is 3b minus a. Now that we've looked at midpoints, we're going to extend this and look at questions with ratios. So let's take this diagram here. And the basic information is given to us. OA is 3a and OB is b. You can see those on the diagram. But we're going to add even more information. We're going to say that OC is 5 lots of OB, and there's a point X which is on the line AB, there's a point Y that's on the line BC, and then these two ratios are true. AX to XB is 3 to 1, and BY to YC is 2 to 5. And then we're going to work out some vectors again in terms of A and B. So we're going to start with the vector AX. So we were told that OC is 5 lots of OB. So OC is the vector from O all the way to C. So this really long line here. That must be 5 times as long as the vector from O to B. And you can see O to B in the diagram, that's just B. So the whole length from O to C must be 5 lots of B, or 5b. It is then quite easy to see that B to C must be 4b, since the total length of the line is 5b, and OB is 1b, BC must be 4b. So we put a 4b here. Next we're going to look at this part here, where it says AX to XB is in the ratio 3 to 1. So X must be some point on the line AB, and since the ratio is 3 to 1, it's going to be closer to B than it is to A. So something like this, where the distance from A to X is 3 parts of the ratio, and from X to B is 1 part of the ratio. Then we can do a similar idea with the point Y. So the ratio of BY to YC is 2 to 5, so we can place a point Y on the line BC. It's going to be closer to the point B since that has a smaller part of the ratio, so somewhere like this, where from B to Y is 2 parts, and from Y to C is 5 parts. Then we'll return to the question. We're trying to find the vector from A to X. Let's take a closer look at the line AB. So we wrote down that X was a point on this line, so we end up with these ratios, 3 to 1. Now if this line has 4 parts of the ratio in total, from A to X is 3 of those parts, so it represents 3/4 of the line. Since from X to B is only 1 part of a total of 4 parts, from X to B is 1/4 of the line. This means we could write the vector going from A to X is 3/4 of the length of the whole line from A to B, which we would write as 3/4 of AB. Now we can just work out the vector AB and then do 3/4 of it. So just like before in the previous question, we write 3/4 then a bracket, then inside this bracket we'll find the vector AB. To get from A to B, I'm going to bring the green dot back, and we'll go from A to O first, which is the vector AO. That goes against the direction of that arrow, so negative 3a, and then from O all the way across to B, which is just B, so plus B. We can now expand this bracket. We need to do 3/4 of negative 3a. To do this, you'll multiply the 3 by negative 3, which is negative 9, so it's negative 9/4 of a, and then 3/4 times b is just 3/4 b. So this is the vector from A to X. You may be tempted to try and convert these fractions into decimals, but in most cases, writing your answers as fractions is going to be easier in vectors questions. Now let's have a look at another vector, this time the vector from x to y. I'm going to bring the green dot back and we need to find a journey from x to y. I'm going to suggest we go from x to b, which is the vector xb, and then we go from b to y, so we add to this the vector by. Now we just need to work out these two vectors. So let's do the vector from x to b first. So we're looking at this part here. In the same way that the vector from a to x was 3/4 of the vector from a to b, the vector from x to b will be just 1/4 of the vector from a to b. So it's 1/4 of the vector AB. We'll use this idea with by as well. To get from b to y, we're looking at this part here, which is 2 parts out of a total of 7 parts of the line from b to c. So this is 2/7 of the vector BC. Now we just need to work out the vectors AB and BC. Well, we actually did AB a moment ago, so it's 1/4 of what we did before, which is -3a plus b, plus 2/7 of the vector from b to c. Now we actually wrote the vector from b to c down right near the start of this question. It was 4b, so 2/7 of 4b. Now we just need to work this out. So we can expand the bracket in the same way we did before. We do 1 times -3, so -3/4 a, and then 1/4 times b, so 1/4 b. And for this last part here, we'll multiply 4 and 2, which is 8, so it's 8/7 of b. Now we do need to simplify these by collecting the like terms. There's only one term in a, so -3/4 a, but for the b ones we can add these together. When we add fractions, we need a common denominator, so we're going to make these both out of 28. So 1/4 b will be the same as 7/28b, and 8/7b will be the same as 32/28b. So we have -3/4 a, and now we can add these together. We do 7 plus 32, which is 39, so it's 39/28b. Next, we're going to take a look at a property of parallel vectors. So if we take a vector from a to b, and let's call it for sake 2a plus 5b, then we draw another vector from c to d which is parallel to this, so it goes in the same direction but it's longer. This could be 4a plus 10b. And we'll do a third one from e to f that's longer still, but also parallel, so 6a plus 15b. So we could write down the vector from a to b is 2a plus 5b, and the vector from c to d is 4a plus 10b. But we could factorize this one here. There's a common factor of 2. So if you factorize out a 2, we could write it as 2 lots of 2a plus 5b. But this part here, 2a plus 5b, is exactly the vector ab. That's 2a plus 5b as well. So we could replace that 2a plus 5b with the vector from a to b. In a similar way, the vector ef is 3 lots of the vector ab. So what we've written here is that the vector cd and the vector ef are multiples of the vector ab. And this is not by coincidence, it's because they're parallel. So we've observed that if two vectors are parallel, then one vector will be a multiple of the other vector. The opposite is true. If two vectors are not parallel, one vector will not be a multiple of the other vector. These weren't the only ways we could have written these down. If CD was twice as long as AB, then we could write that AB was half as long as CD. If EF was 3 times as long as AB, then we could write AB is 1/3 of EF. And you could even write down statements linking the vectors CD and EF. CD would have been 2/3 of EF, and EF will be 3/2 lots of CD. So the really important thing to understand here is that if one vector can be expressed as a constant multiple of another one, then they must be parallel. Let's use this in some questions. So for this question, we're going to have a diagram, and then all of this information which is actually on the diagram. And we're going to answer this question. Show that the vector OC is parallel to the vector AD. So we just learned that if two vectors are parallel, one of them must be a multiple of the other one. So we're just going to work out these two vectors and hope that that's the case. So let's start with the vector from O to C. To get from O to C, we could go across from O to B first, so the vector OB, and then from B all the way across to C, so we add to this the vector BC. Now we know both of these, we can see them on the diagram. OB is 9b and BC is b minus 5a. If we simplify this, we've got 10b minus 5a. So OC was quite simple. But what about AD? So to get from A to D, we'll bring back the green dot, and we definitely can't go there direct. We might need to do a bit of a tour around this diagram. So we'll start by going from A to O first, so the vector AO, and then we can actually go across O to C here, since we worked that out previously. So plus OC, and then from C to D, so we add to this the vector CD. Now we need to write all those vectors down, so from A to O is the opposite direction of that arrow, so minus 4a. And then from O to C, well that's the one we worked out in the previous part, 10b minus 5a. And then from C to D, that's on the diagram, that's 20b minus 6a. Then we just need to simplify. So we've got negative 4a, subtract 5a, subtract 6a, which is going to be negative 15a. And then we've got 10b plus 20b, which is plus 30b. Now we could reverse the order of this, so rather than negative 15a plus 30b, it's 30b subtract 15a. So remember, we were trying to show that these two vectors are parallel. And we have both of the vectors. OC is 10b minus 5a and AD is 30b minus 15a. And if you look carefully, you can probably see that if you multiply the OC one by 3, you get the AD one. 3 lots of 10b is 30b, and 3 lots of negative 5a is negative 15a. So we can write down that the vector from A to D is 3 times the vector from O to C, therefore they are parallel. Next, we're going to look at another important fact about vectors. We're going to take two parallel vectors again, so ones that look like this, but not only are they going to be parallel, they're going to form a perfect straight line. So for instance, in the bottom left, we could call this point A. Those two vectors meet at a common point, which we could call B, and then there's a point at the top, which could be C. So the first of these two vectors is the vector from A to B, and the second one is the vector from B to C. So we know that these two vectors are parallel, but also they both contain the point B. We can use this information to write down a statement about how to check that 3 points form a straight line. We would say that if A, B, and C form a straight line, then the vector AB and BC must be parallel. Notice again here we have the point B in both of those vectors. It doesn't have to be the point B that's in common though. We could also look at the vectors AB and AC and they must be parallel. Notice this time both of those vectors have the point A. And it could also be the point C. So the vectors AC and BC must also be parallel. So if you want to prove that 3 points form a straight line, you need to find two vectors going along that line that involve 1 point in common, and those two vectors must be parallel. If they're not parallel, it's not a straight line. Let's have a look at how we can use this in a question. So if we take this diagram here, and all of this information about the vectors, and the question we're going to answer is, show that PQR is a straight line. So we know from what we just did that to show PQR as a straight line, we'll need to find two vectors. One of those letters must appear in both of those vectors, and we need to show that those resulting vectors are parallel. So the options we have are we could find the vector PQ and QR, or we could find PQ and PR, or we could find PR and QR. When I look at this diagram, I can see that PQ is going to be easy to work out, so I'm going to do that one first. To get from P to Q, I'm going to go from P to O first, and then once I've done this, I'm going to go from O to Q. We can see that both of these vectors are actually given in the question, so to get from P to O, we go against that arrow, so negative 6a, and from O to Q, we go along the arrow, so plus 9b. So now we need to decide if we're going to do PR or QR to go with this, and looking at the diagram, I think QR would be easier. So we're going to work out the vector from Q to R, and at first it looks like we don't have all the information we need, but we are told in the question that OP is equal to 2 lots of QS, and we do have OP. So if OP is double QS, then QS must be half of OP. If OP is 6a, then QS must be half of this, which is 3a. So we can put from Q to S onto our diagram at 3a. We can now get from Q to R by going from Q to S, and then S to T, and then T down to R. And we have all of these vectors on the diagram now. So from Q to S is 3a, and from S to T we go against that arrow, so we need to change the signs of those terms, so it'll be negative a and plus 4b. And then from T to R we go with that arrow, so it's minus 4a minus b. Then we need to collect like terms here. We've got 3a, subtract 4a, which is negative 2a, and then we have 4b, subtract b, which is plus 3b. So we've now found the two vectors we need, and we just need to check that they're parallel. So if we look at negative 6a plus 9b and negative 2a plus 3b, we can see that these are parallel because one of them is a multiple of the other. If we take 3 lots of QR, we'll get PQ. So we can write that PQ is equal to 3 lots of QR, and then we write a statement, something like therefore PQR is a straight line. It's worth remembering in this question that we weren't just showing they were parallel, we specifically chose vectors that had a common point, in this case Q. And now we're going to have a look at one final question. So in this question we have this diagram and we're given this information. OA is 9a, OB is 4b, OC is 5b minus KA, where K is some constant, and OB to BD is in the ratio 2 to 3. And the question for this one says, given that AB is parallel to CD, find the value of K. Because we've been told that AB is parallel to CD, we're going to try and work out vectors for AB and CD first. Let's start with AB. To get from A to B, we can go from A to O, and then O to B. And we know both of these vectors, they're given in the question. To get from A to O is negative 9A, since we go in the opposite direction to the arrow, and to go from O to B is just positive 4B. So that's the vector AB done. What about the vector CD? To get from C to D, I'm going to go from C all the way back to O, and then O all the way to D. Now we know the vector from O to C, that's 5b minus Ka, so the vector in the other direction will be the same one, but we reverse those signs, so it'll be Ka minus 5b. Then we want to find the vector from O to D, but we don't have this vector. We do have part of that line from O to B, but we need the part from B to D. But conveniently in this question, we've been given those in a ratio, it's 2 to 3. So if we write out OB to BD in the ratio 2 to 3, and underneath the OB we put the vector we know, which is 4b, then we can see that this here has been multiplied by 2b. 2 times 2b is 4b, so we do 3 times 2b, which is 6b. So the vector from B to D must be 6b. So now we want the vector from O all the way to D. We can add those two together, which is a total of 10b. So it's plus 10b. There's some simplifying we can do here since we have two vectors with b's. Negative 5b plus 10b is positive 5b. So we've now written down the vectors for AB and CD. Remember in the question it said that these two vectors were parallel. We know that if two vectors are parallel, one of them is a multiple of the other. Now since we don't know what the multiple is in this one, we're just going to call it n. So we could say that AB is n lots of CD, where n is some multiple that we don't know at the moment. So let's write in the vectors. AB is negative 9a plus 4b, and this equals n lots of CD, which is Ka plus 5b. If we keep the left-hand side the same, but expand the right-hand side, we do n times Ka, which is nKa, and n times 5b, which is 5nb. Now at the moment this may look overly complicated, but remember that n and k are just some numbers that we need to find. What we're going to do now is use a technique called equating coefficients. Because these two vectors are equal to each other, we must have the same amount of a's on the left and on the right, and we must also have the same amount of b's on the left as on the right. So if we look on the left hand side, we have negative 9a, and on the right side we have nKa. This means that negative 9 must be the same as nk. So we write that down as an equation, negative 9 equals nk. We can do the same thing with the b's. On the left hand side we have 4b's, and on the right hand side 5nb's. So 4 must be the same as 5n. So we write that as an equation too. Now the equation on the right hand side can solve really easily. If you divide both sides by 5, you end up with 4 over 5 equals n. Now that we know n, we can substitute that into the other equation. So it's negative 9 equals 4/5 of k. We can then solve this equation. If we multiply both sides by 5, we get negative 45 equals 4k, and then divide both sides by 4. We'll get negative 45 over 4 equals k. So in this question, we were asked to find the value of k